In this video, I'm setting up a basic setup for networking on the Beaglebone, which is to use a very clever built-in USB network adapter that comes with the Beaglebone drivers. It's a clever adapter because it means that we can create a mini network attached to our PC so that we don't have to have a separate switch or router, and that we don't have to actually connect a network cable to the Beaglebone in order to start connecting to it and starting to use it. This is useful because an awful lot of configuration problems can arise when you start to interact with the Beaglebone the first time, and it can be difficult to set up networks, for example inside universities where you don't have access to the network equipment in order to make changes to how it behaves. Because it's the most popular platform that our students are using, I'm doing this under Windows, and I'm using Windows 7 here. The setup is much the same for Windows 8, with the exception that you might have to reboot to allow drivers that are non-certified. Apart from that, everything should be much the same. At the end of this video, you will have your Beaglebone set up so that you can connect to the Beaglebone to the PC with just a single USB connection, and that your Beaglebone will be able to connect to the internet to download files directly and to use tools like Git. Okay, so the first thing we might want to do is to install to the latest image. If you go to beagleboard.org, you can go in under the Beaglebone setup, getting started, and there's a very good guide there on how to install the latest image. In this case here, I'm working with the latest image, which is 2013. So it's the 20th of the 6th, 2013, and that's the one that's on this Beaglebone board that I'm about to plug in now. So if you've got a recent board, there's probably little need to do that. So the first things first, I'm just going to plug in the USB connector, and that's all I'm connecting to the board. There's no network adapter plugged in, there's no network cable plugged into the board, nothing else, so just the USB connector. So when you do that, it should take a few seconds. And I can see the lights are flashing on the Beaglebone, and it's starting to boot my Beaglebone. So on the H drive, you'll see that we get our Beaglebone folder, and the first thing you want to do is install the drivers. So we can open this here and go to Windows and install. In this case, I'm using Windows 7, so we can install the drivers. Ask me if I want to continue. Yes. So welcome to driver installation. Their device drivers are not certified, so we still want to continue anyway. So install the driver software anyway. So this takes quite a bit of time. I'm going to speed this up in the video, but it takes quite a bit of time, and it'll prompt you a few times. Are you sure? Are you sure? Are you sure? And the reason for that is because it's installing multiple different drivers onto your Windows machine. So don't worry if that happens. So once you've gone through this process, a little dialog like this should pop up, and you can see here that we have all of our device drivers ready to run. Again, in this case, I've only got the Beaglebone connected to the PC with a USB cable, so press finish. So if everything's working correctly, we should be able to open a new tab and type in 192.168.7.2. So that's the address of the Beaglebone on my new little network. So here's the beagleboard.org page. It's been served out by 192.168.7.2. So this has been served out by a web server that's installed on my Beaglebone. And this is good news because it means now that I have a full connection to my Beaglebone. What I would recommend next is that you install Putty. So if we Google Putty, you can see that we can download Putty directly. It's a free Telnet and SSH client. So download it. Probably the version you want is this one down here, a Windows installer for everything. So install that onto your machine, and then you end up with Putty installed on your machine. So I can execute Putty. So once Putty is run, we can set up a profile for this. So let's edit this one, load this one, and just change it to my new address 7.2. And we can hold on, we'll delete that and just do it again. So let's save one for this. Save it as port 22 SSH Beaglebone. So save that. So now I've got a new one that I can just double click every time I want to start it up. So Putty is running, and we want to accept the fingerprint, and we want to log in as root, and the password is root. So everything is in order here. This is just a blank, absolutely brand new distribution of Angstrom. So it's Linux 3.8.13, and it was built in June of 2013. So that means we're up and running. If I want to connect back to the PC, 2.168.7.1. So the PC appears as .7.1 on my network, and the Beaglebone is .7.2. So we have a private network here. The only thing here is that if we ping, we have a bit of a problem. So at the moment now, we've everything set up in order to connect the PC to the Beaglebone and the Beaglebone to the PC. So if you're doing some sort of client-server programming, which we want to do in an assignment later, well then we're set up and we're fine. But the problem is this doesn't allow us to access GitHub or even to update the packages. So we want to have a setup where we can actually enable IP traffic to pass through this little network, .7, right through to your home network. And the way we do this is within Windows itself, and it's a little bit tricky, so I'm just going to go through the steps. So we go in and we load up our adapters. So I think you can go here into control panel. Control panel, and into network and internet, and network and sharing, and we want to change adapter settings. So on my computer I have a Bluetooth network connection, which you can ignore. I have a VPN, which you can ignore. So the ones that are important here are, well, the VirtualBox, I have that there, you can ignore that for the moment. So these two here, local area connection, which is my gigabit Ethernet network, that's a fixed wire desktop connection. In my case, if you're connecting to the wireless LAN and you're using a laptop, you'll have a different adapter there. And this is the one that's important here, local area connection 7. This is my Linux USB Ethernet RNDIS gadget. So this is effectively like it's like a Wi-Fi adapter connected to my PC. So the Beaglebone is pretending to be a Wi-Fi adapter, and we now need to in some way bridge these two or join these two so the traffic from this network is passed through this traffic network. And the way we do that is to go into properties and we go into sharing. And we want to allow network users to connect to this computer's connection, and we want to allow, in this case, local area connection 7. So that's the one there of my Linux USB Ethernet adapter. So choose that. We don't need to give it control, and we press OK. Now, what happens here, and this isn't too bad, what happens here is PuTTY is killed. The network connection is killed. And I'm not really sure exactly why this happens, but if we look under the settings here of our USB, our Beaglebone adapter, under TCP4, you see that for some reason it's given it a fixed IP address. So we just have to change this back to obtain an IP address automatically and press OK. So close that, just give it a second. Okay. And then we can open PuTTY again, and we can open Beaglebone. That's this profile is saved, so we're connecting to 192.168.7.2. So log in as root again, and password root. So at the moment now our PC is configured to allow traffic to go through, but we have to tell our Beaglebone to send traffic to our PC, TCP traffic to our PC, in order that it's routed through. So again, -A, just show the version again. So the way we do this is we have to, and I'll just do this, set this up initially again. If we just ping, it's not going to work. Okay, so we need to now route the traffic, and the way we do this is by typing /sbin. We're logged in as root, or OOT, we're logged in as root, and we want to route, ROUTE, our data traffic through our default gateway. So /sbin/root add default gateway, and we want it to our PC, 192.168.7.1. Okay. Now, if we ping an IP address, let's ping 8.8.8.8, which is the IP address of the Google DNS. So you can see now we have full access to Google's DNS. So that's good news. It means now we need a way now of actually resolving our names, because even if we do this at this stage, ping google.com, we've unknown hosts. So now we need to just do one more change. We go into cd/etc, and there's a file here called resolver.conf. And at the moment, it's routing to resolve the names. It's just using a loopback address, so it's using the Beaglebone itself. So we just want to edit this, so we can use nano resolve.conf, and we can add in name server 8.8.8.8. Control X and save, yes, write it to that file. So now we can ping Google, and you can see that everything works. Good, we've got a ping time. Control C, and we can also, if we go to our home directory, we can just cd, gives us our home root. We can do this. We can get a little directory listing. See, we just got desktop. We can do git clone github.com/Derek/Malloy/EE402, and it cloned in here. So now we have a directory EE402, and in this directory there's test programs. So we can go into test cpp, and we can build this. Okay, so that tests that we have our test program on our Beaglebone. So you can see we have a full C++ compiler set up, and we're ready to go. So we can call this manually as well by saying g++ test.cpp -o. We just call it test2. So you can see here that the compiler is compiling, and we've built test2. So now you can see that test2 is built and it executes, so we're able to build applications on our Beaglebone. One thing you'll notice there is that the date is if we go ls-l, you see that the date of all the files is January the 1st, and it's the year 2000, and that might cause problems later on. So if we want to fix our date, I have a blog entry on how to fix it permanently. But if we just want to do a one-off fix every time we log into the Beaglebone, we can just go /user/bin/ntp date -b -s -u, and I'll just try ie.pool to go to Ireland.org. Give it a second. I don't like that's taken time. And that worked. Good. So we've got our proper time. So we don't have a battery backup on the Beaglebone, so therefore the data is going to be lost every time that we reboot the Beaglebone. There's no BIOS, so and that's consistent with most embedded Linux devices. So if you want to know how to set that permanently, you can follow the link below to my blog where I set it permanently. But it's not too much trouble to maybe run this every time you want to reboot your machine, reboot the Beaglebone. So that's that installation. The next step that I'm going to do is, if that works for you, so if you can now ping and connect and you've got full access to the internet from your Beaglebone Black, you might want to make these changes permanent. So that's what I'm going to do next. The problem we have with the current configuration is when we reboot, you'll see that we no longer have access to our network. What I'm going to do here is, inside the when we did git clone, I'll just do it again, git clone /e402. It already exists. So if it didn't already exist, we go into this e402. I've added some scripts. So if you go into the scripts directory, you'll see I've added a script called start USB network. So you can copy that script to your root directory, ~/ that copies it to our root directory. So we can go back to our root directory, and you'll see we've got the start USB network setting there. So all I've done here is placed the settings inside a little script. Just make sure that it's executable. It should carry over from Git as executable, but if it doesn't, just chmod ugo plus executable the start USB network script. That makes it executable. So assuming that's executable, we can just do /start. And all that does is it does exactly what the steps I went through. Now, it is possible for us to build in and make this so that this automatically happens on boot. The only problem with that is that means that you will have difficulty if you start connecting in a network cable in and trying to use your regular network adapter. So we'll just, if you don't mind, we just hit /start USB network every time we boot our machine, just for this module, and we can ping google.com. So we're all up, and I put in the time there as well. Hit Control-C and date. You can see it automatically updates in that script the time to the current time as well. So just with having that there, it means that if you just leave that then in your root directory, you can just execute that every time you boot your device. There's one other thing I added into EE402 under scripts, and it will be useful if you copy this across. It's just a Git configuration. At the moment, Git is not set up properly, so if you want to use Git over HTTPS, it won't work properly. So if you just copy this script, cp git config // dot. Now, very importantly that you put the dot in there, git config. Okay, so if we go back to our root directory and we go ls-al, you should see now a file here called git config, and this just means now that you're able to use HTTPS with GitHub, meaning that if you want to create your own repository and upload your own source files to your own Git repository, that HTTPS will work correctly now. We can try it. I'll just remove the directory EE402, remove it -r, EE402, and let's just git clone again, and this time we'll use HTTPS. And you'll see that it's cloning into EE402 to transfer the objects, and this means now if I was to do a git push with the username and password, that it'll allow me to update the repository. So EE402 is there with all of the files. And I'll add to this repository, it'll probably be longer when you get it, I'll add the source code for the course materials to this as well. So you're up and running, you have the Beaglebone, you're set up and ready to go for general C++ coding directly on the Beaglebone, but more importantly for communicating to Beaglebone and connecting the Beaglebone to the internet. I'm just going to create a short video shortly, soon after this, on setting up the Java environment so that we can use that within our module as well. Thank you.